Okay, so answers to the vector quiz here. We have a crate, 75.5 kilograms. We are pulling it with a rope at an angle of 40 degrees, 145 newtons, and we need to find two things: the acceleration of the crate and the normal force, in other words, the force that holds up that crate. So basically what we need to find the acceleration is our horizontal vector of force, and then we're just going to go ahead and divide that by the mass. So if we want to find horizontal, we need the adjacent, so we're going to use cosine. So cosine of 40 degrees is going to be equal to the adjacent, which is what we're trying to solve for, over the hypotenuse. But remember, if we do a little bit of algebra, we're going to go ahead and multiply that by that hypotenuse. So 145 times the cosine of 40 degrees, that gives us the adjacent, which is 111. So adjacent, which is the same as the x. Let's label it as that. Let's label it x because that's our horizontal. That's going to be 111 newtons. So that's our horizontal force here is 111 newtons. That force is acting on an object that weighs, that has a mass of 75.5 kilograms. So all you have to do then is divide that by the 75.5 kilograms. And if you do that, your final acceleration here is with 3 sig figs, 1.47 meters per second squared. Okay, so that's your best answer with 3 sig figs, because I see 3 sig figs in every number in our question. Okay, so that's the first part. The second part now, if you use 10 for gravity, this object will have a weight of 755 newtons. But of course, we are going to exert some upward force as we pull on it with that rope. So, if we wanted to find the upward or the vertical force, we're going to have to use sine because that's the opposite. So we're going to be sine, actually, let me erase that. We should be 145. So 145 again times the sine of 40 degrees. And when you do that, you get the vertical force, which in this case is about 93.2 newtons. Then you take that 93.2 upward, and you're going to go ahead and subtract it off of this 755. So basically 755 minus 93, that's a 5 here, by the way, that's a 5. So 755 minus 93 looks like 662. Okay, so get that 662 newtons with, again, 3 sig figs. That's an N for newtons. And there are your two answers for part 1. Question 2. Now you need to find equilibrant forces here. So we start with basically our quadrant here. And we are going to do 180. So we're going to do the horizontal first. So basically we're going to come 180 this way. And that's going to represent 135. So this is 135. And 270 means straight down. So 270 degrees is that way. And this is 36.7. So there is our right triangle. Okay, so 135 is the horizontal, 36.7 is the vertical. So right away we need to find the resultant force of this. So we're going to go ahead and use Pythagorean theorem. So it's going to be 135 squared plus 36.7 squared. Find the square root of that whole thing, and that's going to give us our resultant force here. And if we do that, we should get a force of about 140. Depending on how you round it, now I know we do need 3 sig figs, so if we wanted to put a decimal there, or if it came up to like 139, or whatever the case may be, but we did need 3 sig figs there. So there's our force in newtons. Now we also need to find the angle here. So we're trying to find this angle theta in here. In this case, once again, we're going to use the inverse tangent. So tangent of theta is going to be equal to opposite over adjacent. So if we want to find theta, we'll need the inverse tangent of opposite over adjacent. So theta will be equal to the inverse tangent of 36.7 over 135. And when you do that, you get an angle theta of 15.2. Now, that's very, very close to our final answer, but it's not exactly our final answer because what we really need is the equilibrium force. Now, here's what actually happens, and this is what tricked up some of us. This 15.2 degrees is this angle right here. If we were to give that angle from the origin, of course, it would be over 180. It would be basically 195. But what we really want is the exact opposite angle of that, which, if you think about it, from this origin line is actually 15.2 degrees. So your final answer is just 140 newtons at 15.2 degrees, because this is actually the equilibrium force from our origin line, and that 15.2 degrees is the exact opposite 180. So it's almost like you add 180 and you subtract 180. You're kind of back where you started. Okay? Anyways, that's the final answer, 140 at 15.2. Okay, so last one here, number 3. We've got a box, it's 55.5 kilograms. We're pushing it up a ramp at an angle of 25 degrees. We are applying a force of 335 newtons. We need to find the coefficient of friction if the box has no acceleration. Now the problem is here, this is moving, so we can't just use the tangent of theta. We do have to find the coefficient of friction using this equation. Force of friction is equal to mu times the normal force. Okay? The normal force is actually pretty easy. It's just the perpendicular force. So the perpendicular force should be the cosine of theta. So weight times the cosine of theta, which in this case is just going to be, remember, the 55 kilograms you need to multiply by gravity, so we can say 555 newtons times the cosine of 25 degrees. And when you do that, you get the perpendicular force, which again is the same as the normal force, is going to be about 503. So 503 newtons is our normal force. We've got half of what we need here. Now we need to determine the frictional force. So now we're going to find the force parallel. So in other words, the force parallel down that box would want to slide with. That's going to be weight times the sine of theta now. So in this case, it's going to be the same 555 times the sine of 25 degrees. And when you do that, you get a force parallel of 234. So, as of right now, we have applied a force of 335 newtons on this box to slide it. We know that 234 newtons of that force is going to be canceled out by the weight of the object wanting to slide back down. Now what we need to find is what the heck is the frictional force. So there's got to be some frictional force here slowing us down as well, because there is no acceleration. So these three vectors have to add up to 0. Okay, well, 335 we put in, 234 gets canceled out, so the rest of what must be here, the frictional force, must be 101. Okay? So we know now that our frictional force is 101 newtons. There's the last piece of the puzzle that we need. So we plug this in now. I kind of ran myself out of room here. We'll try and fit this in here. So we've got a frictional force of 101. We need to find mu. Our normal force is 503. So divide both sides by 503. So normal force here, or I'm sorry, mu, coefficient of friction, is basically 0.2. I think if you round it off to 3 sig figs, which is what we want, 0.201 is what we're looking for. So there's your best final answer. I don't want this as a final answer. Okay, so there's your best final answer.